I'm going to start a series of videos on Euclid's elements. Now, it may take me a while to get all these done because some of these Euclid's elements are quite complicated, so be patient with me. But I'm going to start with proposition number 1. Now, I know a lot of people are going to say, well, there was a bunch of definitions before that, and I will get to those definitions. But today I'm going to talk about proposition number 1. This is a geometric proof, all right? Now, if you've had any kind of geometry at all, you're used to these kinds of proofs. But some people don't do as well with these proofs as other people. So I'm going to help you out. In Euclid's Elements, he has his first proposition concerning equilateral triangles. These equilateral triangles are equal on each side. In other words, side A is equal to side B, and side B and side A are both equal to side C. But the question is, how do you make them? Well, you could take a ruler and make them, but then you could make Euclid mad. You say, well, Euclid's not around anymore. Well, no, that's true, but if you were around when he was around, you'd make him mad. And the reason for that is because he allowed people only to use a compass and a straight edge in his class. You tried to bring a protractor, he threw you out. That was the way it was. So, in this particular case, since you would only have a bow compass and a stick, not really a measuring stick because there'd be no numbers on this thing, but it would be a real smooth stick. Okay, so what you'd have is just those two tools, and you would have to draw an equilateral triangle from those two tools. And you say, well, that's impossible. No, it's not. Take a look at this. The first thing I did was I inscribed circle A. Now, in Euclid's day, they really didn't have, they had papyrus as far as that's concerned, but they didn't have a whole lot of papyrus. So often you would see people inscribing things on blocks of wood. Now, that would take a little bit longer, but it can be done. Alright, so they just kept the term inscribe, and they just kept going on with it. So here we go. I inscribed circle A on this piece of paper. And as you can see, circle A is green. Then I inscribed circle B on this piece of paper, and as you can see, it's blue. And then I drew the radii of the circle. One of the things Euclid said before he started these propositions was that all radii of a circle are equal. And you're saying, well, what's a radii? When you draw a line from the center of a circle to its outermost edge, that's a radii. And as you can see here, I drew a radii from the center point D to the outermost edge E. And then I drew a radii from the center point D to the outer edge C. Okay? Now, as you can plainly see, the green circle A and the blue circle B are overlapping each other. As a matter of fact, the edge of circle A passes through the center of circle B, which is represented by the dot E. Okay? So I drew lines DE, which is a radii of circle A, and I drew line DC, which is another radii of the circle A. Now, looky here. We have CE. This is a line that comes from the center of circle B, which is E, and goes to the outermost edge, which is C. Believe it or not, DE and DC are the same length. Why? Because all radii of a circle are equal. ED and EC are also equal because all radii of the circle are equal. Well, DE is equal to ED, obviously, and EC and DC are equal as well because, like I said, all radii of a circle are equal. So this is an equilateral triangle. We have just successfully drawn an equilateral triangle. You can see it in red right here. And you can do this for yourself anytime you like. I will cover another one of Euclid's propositions in a future video, so stay tuned.